In today's video, we'll be talking about momentum. After watching this video, you should be able to define what momentum is and understand how momentum and impulse are related. So let's get right to it. Very first thing I'm going to talk about is, well, what the heck is momentum? Momentum basically is referring to the amount of motion that an object has. So one way I kind of keep in mind with momentum is basically the idea of mass in motion, things that are moving. Okay, so momentum has to do with the mass of the object, so the mass and its velocity. So that kind of gives you a hint in terms of what the equation would be for momentum. Momentum, which is represented by a p, oddly enough, is equal to mass times velocity, or another way of saying it is p equals m times v. The units are kilograms times meters per second, which that makes sense because kilograms are typically what we measure mass in, and meters per second are typically what we measure velocity in. So relatively simple formula, but you do have basically mass and velocity. And kind of something to think about with this formula is if you have no motion, what would the velocity be? Well, that'd be zero, so you'd have no momentum. Okay, so the equation kind of is a guide for thinking. Momentum is a vector quantity. So that means that basically it's going to have a magnitude, a numerical value, and a direction. Again, if you use this equation as a guide for thinking, an object that has a lot of momentum would have a large mass and a large velocity. Now, it really could be just a large mass and even a relatively small velocity. I mean, like imagine even a semi-truck going 5 miles per hour. So it's not going very fast, but imagine trying to stop a semi-truck rolling at 5 miles per hour. That'd be kind of a tough challenge. So you have to kind of keep things in perspective, but usually if you have a lot of momentum, you're going to have a relatively large mass and a large velocity. And so again, think about like a fly versus a car. Well, a car is going to have a lot more momentum because it's a lot more mass than, say, a fly does, okay? All right. So what the heck is impulse? Well, impulse is basically, or the formula for impulse is force times time, or newtons times seconds. Okay, so it's newtons times seconds, which is impulse. And basically, an impulse is the amount of change in momentum. Okay, and one way to kind of look at it is like, here is our Newton's second law, F equals ma, right? Well, if I change a to what actually acceleration is, the change in velocity over time, and I still keep my mass there, so force equals m times change in velocity over time. If both sides of this equation are multiplied by time, so let's say I get rid of the t here, and I put a t over here, I now have the equation for momentum, m times v. Here's my momentum, which I'll represent that with a p, and over here I have f times t for impulse, okay? So impulse equals the change in momentum. Okay, so they are very much so the same thing, but not quite the same. Impulse is asking you how much is the momentum changing, and then momentum is going to be talking about basically how much oomph that mass has as it moves. Okay, let's continue on. So impulse momentum change equation, I mentioned that force times time equals mass times velocity. This will be useful because if I give you some of this information, you can kind of figure out the rest or piece together the rest. Basically, in a collision, an object experiences an impulse or a change in the momentum, right? I mean, when you see impulse, you can kind of see yourself a change in the momentum. And the impulse is equal to the amount of change in momentum. So a football player being hit by another football player is going to experience an impulse. Their momentum is going to be changed relatively quickly, right? If a football player is running down the field and then all of a sudden they're hit by a defensive back, that's going to cause a change in momentum. Or if you're riding in a car and let's say someone, T-bones you in an intersection, your momentum is definitely going to change. You're going to be experiencing an impulse because that car was hit by another car. Okay, so they're very similar, but not exactly the same. They're talking about two different things. Now, there's a special type of collision called a rebound collision. A rebound collision. And the name kind of says a lot. A rebound collision basically is going to involve a direction change in addition to a speed change. And so if you have a direction change and a speed change, this results in a very large velocity change. Okay? So collisions in which objects rebound with the same speed as they had prior to the collision are known as elastic collisions. And that's basically what we're going to focus on in this course. There are things called inelastic collisions, and we really won't get into those too much. But an elastic collision, basically an example of this would be like, let's say this is a wall here. And I throw a ball at this wall with a velocity of, we'll say, 10 meters per second. Okay, so sort of fast. And it hits the wall and it bounces off the wall with a velocity of 10 meters per second. That's called an elastic collision. Basically, the speed at which the ball hit the wall is at the speed at which it rebounded off the wall. And those are the types of collisions that we'll be dealing with for the most part. So here is a example of a rebound collision, and here's that wall, and here's two tennis balls. I'm sorry, the picture's a little distorted. But in case A, we have an initial velocity of 10 meters per second as it heads towards the wall, and then after it bounces off the wall, it comes off with a speed of 5 meters per second. Okay, so you'll notice this is not a elastic collision. It's not perfectly elastic. In case B, we have a speed of 30 meters per second heading towards the wall, and it bounces off with a speed of 28 meters per second. The questions are, which was the greatest velocity change, case A or B? Which had the greatest acceleration? Which had the greatest momentum change? And which had the greatest impulse? Okay, so velocity, change in velocity, well, basically this guy was going 10 meters per second here, and then it bounced off going 5 meters per second the other way. So basically that is a net change of 15 meters per second when it from hitting the wall to bouncing back the other way. Whereas this guy was going 30 meters per second as it headed towards the wall, and it bounced off at 28 meters per second. So that is a net change of 58 meters per second. So I think the greatest velocity change would be case B. All right. Now remember, acceleration is just basically the change in the velocity. So we kind of answered that question already. The greatest acceleration would be definitely case B because it had the greatest velocity change. I mean, acceleration is just basically the change in velocity over time. Now, these two, momentum and impulse, are kind of the new things that we're learning. But remember, momentum is P equals mass times velocity. So whoever has the higher velocity is going to have a much greater momentum change. Well, who has the higher velocity here, case B or A? Well, B has a velocity of 58, or a net velocity of 58 meters per second, and A has a net velocity of 15 meters per second. So I again would say, well, I think case B would have the greatest momentum change. And as soon as you say that, the change in momentum is the amount of impulse that occurs. And so basically, case B would also have the greatest impulse. So it's kind of a trick question in a way. But this is just being able to look at a picture, analyze what's going on, and then answer some questions with that picture. All right, that takes care of today's video. I will see you guys next time.